Okay. Awesome. Welcome, everyone. It's my honor to introduce Tim Benedict today. He's a technology executive with over 2 decades of experience spanning IT, cybersecurity, AI governance, and digital transformation. He's the chief technology officer at Compleak, where he leads the development of AI-driven compliance and security solutions, helping organizations navigate regulatory requirements, mitigate risks, and adopt AI security. His work focuses on building resilient, scalable platforms for empowering enterprises to integrate AI while maintaining transparency, security, and operational control. And today he's going to talk about what the future of AI depends on. Welcome, Tim.
Yeah, thank you. Can you hear me all right? Yeah. Well, thank you for having me today. Thank you for being here. I'd like to talk today about the view of AI through industry and the private sector. As an academic institution, we have to work closely to ensure that we're aligning principles. And so what I'd like to do is just really define what AI means today, what people are actually trying to do with it, what companies are trying to do with it, and what is the realistic challenge of what is available to just a general purpose approach. So when I speak to industry and private sector organizations, it depends really on where they're at. But as you can imagine, if you are a heavily regulated industry, whether you're financial services, healthcare, AI is going to both solve many things for you and also introduce some very complex variables that are quite challenging and new. And what we've seen over the last 2 years is really the democratization of AI in a way that can be used in a pragmatic way. So I can take a credit card, I can go to said AI offering, and I can use it. But what's also happening is legislation, regulatory statutes are also emerging, and you have to basically understand, okay, if I'm going to really use AI meaningfully, I have to be able to allow my users and the folks that I really want to push and drive this business value. And so I'm really wrestling with, regulation, governance, understanding what penalties I will and won't have. Traditionally, cybersecurity has not really been a heavily penalized control. Privacy, data privacy obviously is with GDPR and HIPAA and whatnot. And then you have some elements of compliance if you're heavily regulated and needing to show different security controls, resiliency, uptime, and things like that. But AI offers a different element because it's new. It's new because it's readily available. So now I'm looking at a challenge of privacy controls, cybersecurity, and also governance compliance all in one bucket. And so I need to navigate that. So one of the elements really leading that is the EU AI Act. It is a milestone in AI regulation. A lot of global companies are facing, the scrutiny of this legislation, but we've seen its effect in private industry as well. So we've talked to organizations who have looked at the EU AI Act's classification system for AI systems, and they codify that into their governance policies, right? No reason to reinvent the wheel. And when you look at where this is coming from, it's been going on for since 2021, and we're seeing that depending on where you're at from different elements of I'm being regulated by the federal government or I'm being regulated by the state, it can be tricky. And so you really have to understand, okay, if I'm going to really use these elements and I need to understand what a high-risk AI system is to a general-purpose AI system and what I really need to be doing, it can get into a very complex conversation very quickly. So really, when you look at, okay, what does an AI classification system mean? What is the AI doing? What access to information does it have? How am I going to use it? And really, how am I connecting it into my enterprise systems? So if I have a limited risk AI system where, let's say, I'm using moderate types of data and I'm using it to do batch processing or something that AI is good at, and I can just connect it to an inferencing endpoint. That's a limited risk AI system. But my high risk AI systems aren't just things that can do bias or comply with regulatory compliance or help with manipulation errors, right? what we're seeing in the industry isn't or organizations are not just going out and have these huge training data sets and they're fine-tuning these models and hosting them in their data centers. They are using SaaS platforms. They are using things like OpenAI and sending things out to API inferencing points. That is what's being used because that's what's easy, right? That's the thing that is, I can start out with that. If I'm a small organization that is highly regulated, I'm not going to have the staff and the complexity to understand what my cybersecurity obligations will be, along with what I want the value of AI to be. So when you talk about how AI is with the different types of AI systems, and I can have a transformer model or classifier, that's not the conversation that's happening in the private sector. It is, what is the use case? What is the business logic? What is the defined value? How am I approaching it? And more importantly, how can I protect my business from risk? And within that, I have cybersecurity obligations. Another element besides complex regulatory aspects and governance and compliance is there is a new threat landscape that is from a cybersecurity perspective. So this is an example. It's a MITRE Atlas framework overview. So the MITRE Atlas framework was created to start to track the tactics, techniques, and procedures that can be used against a generative AI system. Now the MITRE ATT&CK framework, which is very robust, really focuses on traditional cybersecurity, which is well over 20 years old. So I am now challenged with, okay, I've got a governance and compliance bucket, I've got a privacy bucket, and now I've got a cybersecurity bucket. And to make things more complicated, traditional cybersecurity controls don't mitigate these tactics. So if you have a prompt injection attempt, if you have a jailbreak attempt, or if you're using like a known hallucination attack, there is no threat intelligence, there's no event correlation, again, all of those robust things. Now, that does not preclude you putting your own model in your data center and using machine learning operations and security operations and securing those elements. But again, think about the complexities, the cost, and the overhead for an everyday organization to be able to do that. Not only would you have to define that case, the business case, and integration, right? Now you're talking about procuring hardware, procuring infrastructure, procuring the expertise to ensure that your pipelines and your training data and all of your data sets are where they're supposed to be. And so it makes the conversation quite complex. And we know that industry needs to adopt AI. We know that. And when you look at some of the advanced research that's coming out of institutions like Purdue, it's not exactly transferable for me to say, oh, this is how I would take maybe a red teaming agent approach to look at the bias in my models. That's a very viable technology, but again, we're talking about the practicality and application within a typical infrastructure. So aligning guardrails is really important to focus on what the business logic of the destination enterprise app that you're really focusing on, right? So if I am, for example, wanting to take my customer relation management system, let's say it's Salesforce, and I want to enable some AI workflows, and I know that I can incorporate that one way or another via a Salesforce offering or one of the approved inferencing APIs, I'm going to need to be able to approach that in a way that will provide the guardrails, create the user experience, and not be a detriment or an overhead to that integration and innovation. So really, when you think about guardrails, it's not a technology conversation. It's a business logic conversation. In that example, you would want to understand how the data is flowing, who is your users, how are they accessing it, what are they trying to model with the data, and more importantly, what is the purpose of the AI itself, and is it interacting in a way that is meaningful but also protected, and that is very hard to do. Large language models are very, very powerful, and they are the primary lens that most of corporate institutions are looking at. The reason why is because you're seeing the ease of use with ChatGPT. When a tech is absorbed by society on a consumer level at that pace, it really becomes the lens, right? So we've seen this with other technologies. So in the late 1800s, right, radio took about 30 years in the early 1920s to become mainstream. In the 1920s, it took about 30 years for TV. Internet TCP is invented or written in the early 1980s by Windows 95. It really blows up. Blockchain in 2008, with Bitcoin coming out by 2018. It's, society is really using it. And that's really where, when I say that AI has been democratized, that's what's really happened over the last 2 years. And so now we find ourselves at a gap. We have this wonderful technology that can be used at scale for personal and professional use, but the logic itself, how to approach it architecturally, using functional requirements, adapting to governance and compliance and cybersecurity, like I mentioned before, that's the challenge. And the way that we're going to accelerate safe AI is to approach that with a guardrail approach that matches the use case and the business logic for the integration endpoint. One of the biggest things that I've learned in the last 2 years is shadow AI is not going to slow down anytime soon. Shadow AI is not a new element. We've seen this many times with shadow IT in the form of cloud, 10 years ago. But what we've definitely seen is that a business unit like human resources or sales, they're the ones that are going to be driving the perceived value of that use case. So if I'm a credit union and I know that underwriting is a really solid use case for AI, how am I going to approach that when I know that from a mathematical perspective, if I have to have a human go in and validate what that AI system is doing from an underwriting perspective? That's a big issue, let alone understanding the data and the constraints. So we know that we have to foster innovation, and we know we have to do it responsibly. So how do we navigate and shift that whole environment to where we're enabling guardrails in a pragmatic way that allows users to innovate and use this technology proactively while addressing the security and elements? So what we do here, and one of the things that we've developed, is a guided approach to really help an organization step through this, right? So when you look at, okay, how am I going to really help somebody, an organization that may not even understand all of the different, let's say, AI technologies that are out there? Who's going to know the difference between Claude, Gemini, OpenAI, and the different elements, and who's better at coding versus who's better at mathematical equations? Well, that's really what's happening. In information technology, artificial intelligence is now its own discipline. So you've got things like networking, you've got things like security, you've got things like data center. Artificial intelligence is now its own discipline, even just from an information technology and integration perspective. I could go into an organization armed with the ability to even just take, let's say, the top 10 AI technologies, and I could have some very compelling conversations by helping people enable what those technologies can do. So the first thing that we really want to help from a guardrail approach is really go through a 6-gate process. Assessing capabilities is really just to help an organization really understand what they're capable of, right? You want them to be self-sufficient. And as AI continues to innovate and change, like look at what happened with DeepSeek early this year. DeepSeek came out and made some very bold claims, got a lot of attention, but really it was a very innovative approach to taking a deep learning model, putting it into a mixture of experts, having a smaller amount of active parameters, and it worked well because you could put it on smaller hardware, you could do things with it that were equivalent to OpenAI and some of the things that Anthropic's putting out, and you could download it from a Hugging Face element and do some endpoint. But there was some worry because if you don't understand where the model came from, and that's just one example, that is going to keep happening over and over. And that was really more of an efficiency play based on what large language models are capable of doing today. So we really want to understand what the business is trying to do, what their appetite of what they can take on from an innovation perspective, and then how you can take them through a process of understanding and providing value. About 2 years ago, the rush to AI was big. Just get to AI. Let's see what it can do. It's a board level discussion. Let's go out and just start using it. That's not the case today. The case today is if I'm going to spend all this time and effort into getting into an AI element, I need to understand what the use case is, so I need to have solid use case planning. So once we understand the organization's capabilities, you really start to hone in on, okay, these are your top, element of use cases. And so again, this is not a conversation from a technology perspective. This is a business conversation. So you don't want to go to them and say, hey, this AI can help you do X. You have a lot of that today already. Everybody's out there saying, my AI system can help you with X problem. Great, that's awesome. I don't need to know about that. What I need to know is, if I go down this path, operationally speaking, is it operationally efficient? Can we sustain and support it? What does that look like? What kind of threat landscape and guardrails do I need to put in place? What kind of privacy measures do I need to put in place? And what that does is it really starts to define high-value use cases where AI can actually be embedded. AI is not a magical thing. It is a very powerful technology, but it will never be the central technology. You will take that and you will integrate it into an existing system, or you will have it do something meaningful. So in other words, if you have, let's go back to the CRM example. AI is not going to replace your customer relation management system. It's not going to do that. What it can do is aggregate very powerfully data into different efficiency elements, maybe scrape, pull data and pull things in. But again, that's a value add, and that's a use case in that system, right? So after you define your use cases, what you have is context. You have business context. So you have an organizational responsibility with artificial intelligence. It's not one department that's going to say, oh, we can use this piece here. Yeah, that might be the use case, but you need to get that consensus so that when you start to move through the use case planning, you've got those identified, and you've got success criteria, and you've got measurable KPIs. Then you move into a solution architecture phase. Again, it's a principle-based approach. So we're not talking about, oh, let's go use Copilot, or let's go directly into this AI tech. What we want to look at here is, how are your systems architected? What is your data sets? Do you have the data if needed? Should I be looking at a RAG deployment? Is the best approach a chatbot? And you can do these solution architectures from a business context perspective, align them to the use cases, and still maintain that architectural approach where you're showing the alignment via functional requirements. The reason why that's really important is because this is the key to really enabling usability within the AI system and getting to that guardrail stage. Once you have that solution architecture, then you can start wrapping controls around it. What we recommend in the third gate is a threat evaluation, so an offensive approach to that solution architecture. What I really want to start doing is seeing, do you have known gaps in this solution architecture that we need to be looking at? So we would look at ethical hackers that would come in, or maybe some red teaming type activities, and really look at some different threats to, let's say, again, a man-in-the-middle attack for an indirect prompt injection. Okay, let's look at your layer 7 elements. And once those areas and those tactics are aligned to the solution architecture, then we can really start getting into what kind of controls and policies and governance and risk do we need to put in place, right? If you remember from the EU AI Act, this is where we can say this is a high-risk system, this is a general-purpose system, this is a low-risk system. And then, we're mapping these back to our use cases, and we're able to show with objective data, here's the threats that we identified, here's the solution architecture, we've already designed these business process use cases. And then a lot of times, especially in the solution architecture phase, we want to use things that already exist. So for example, we are working with a financial institution that is heavily regulated, and they would like to use note-taking. Note-taking is a great example for how AI can be efficient. But if you're regulated and how your data comes in, whether it's an email or whether you're tracking meeting notes or if you have a phone call, all of that has to be tracked. So the data is scattered everywhere. So how are you going to be able to use a standard note-taking system? Well, the answer is you can't, because you're not compliant. So that AI system takes you out of that. And that is not an uncommon case. You would be, well, it's not surprising, but you would be very surprised to know that just even the littlest regulation can disqualify a total AI technology from being able to provide that innovation. So when we look at things like, if you put this system in a controlled environment and you own it, and you can show that you have that observability, and you have people that are actually showing evidence of looking at that, maybe you could use something like Whisper, which is an open source model from OpenAI that basically can read dictation and other elements. So again, going back to applying the risk and compliance pieces, when we look at the solution architecture and the threat evaluation, and we get into the risk and compliance space, that's when we can really start to talk about those guardrails, enabling the compliance elements. And then an ROI analysis is oftentimes really necessary, because if you can show in a very acute way that this use case can work, here are the appropriate guardrails, here's how we're measuring privacy, here's how we're mitigating and securing the model. That's a very, very powerful process to go through. And again, we're not talking tech, we're not talking about the latest AI model, we're not talking doom and gloom with cybersecurity. We're bringing meaningful process and procedures to use cases in a business context using architectural approaches and laying down the appropriate risk and compliance. So if you are following the NIST protocols, or frameworks, maybe the risk management framework for AI is good for you, which you could set that right beside the NIST cybersecurity framework, right? Or if I want to become certified, maybe I'm already ISO 27001 certified and I'm SOC 2 certified. That's great. So then you can add those other controls from ISO 42001, and then again, lay all those things down. And then when it comes time to evaluate that, I can move forward. So let's talk about the common types, the three very common types of AI elements that people are looking at. So when we go through this process, by far, one of the top use cases is chatbots. Chatbots are not new, but they're becoming more mainstream to more people. And I'm sure you've seen any of you follow the news, or you've seen some history of some pretty awful things that have happened with chatbots that are not very well protected. But again, that's why a guardrail approach needs to happen, because a chatbot can do a lot of really good things for many things. And single-purpose chatbots really excel in specific domains like customer support, very autonomous, repetitive elements. I've seen a big uptick in hybrid chatbots where you give them some predictable interactions that are effectively, like maybe knowledge base or element like that. But the context-aware chatbots are super interesting, because memory capabilities for past interactions is really where you're starting to see an AI in an autonomous fashion being able to do that. But the tasks and the user needs in simple queries and complex conversations at scale can add up very quickly inside of an organization. So what kind of guardrail would we want to put here? What kind of mitigation, and really, what is the challenge with a chatbot threat? Well, if you have a chatbot and it's just able to interact with just anybody, your first and foremost tactic you're going to need to worry about is a prompt injection. Inputs, they're not hard to do. Prompt engineering, there's a lot of examples out there. There's some benchmarking tools. Microsoft has a nice one called Prompt Bench that you could use to test the security and implementation of your chatbot. But if I have a chatbot and I allow it to be connected to even, let's say, an ITSM system, and I have somebody who knows what they're doing and they craft it, and I go from a reconnaissance prompt injection to a jailbreak aspect to an evasion tactic, well, then now you have an advanced persistent threat in your organization, because you can get it to do insecure output handling. You can also just want to cause a disruption of service by doing a denial of service attack, limiting auto scaling and resource allocation. And in some cases, if the model is allowed to use in-memory and whatnot, you could poison it by fine-tuning practices, content from insecure pipelines, getting it to do things like a known hallucination, where I'm going to trick a model into thinking that this malicious IP and package is actually valid, and then I can really start to figure out how to do the poisoning of the actual data. But corruption of long-term memory is really dangerous, because we're going to alter what the model knows and what it thinks it remembers, and it can start answering falsely. And so one of the more dangerous things that we saw from a threat intel perspective, we noticed that there were chatbots that were calling and impersonating voices in a deepfake style, but they were getting a lot of success in certain age demographics. And so they were exploiting chatbots and using them in different elements, but the actual service was never detected because it was just a normal usage, right? So they were embedding things into these chatbots, using them at periodic times, and it sprawled 3 continents, and it was very, very bad. And so these are things that will happen more and more as AI gets used, but that's why we want to talk about putting in the appropriate guardrails and mitigations ahead of time. So if you go back to that process, and this is one of the use cases, we would have basically picked out a series of chatbot elements. We would have put an offensive security approach to that. We would have identified any of those tactics, techniques, and procedures, and then we would have put in a governance system to at least be able to correlate those events, see who's trying to access the system, and then hopefully mitigate that long term. One of my favorite topics, not new again, but really, really a lot of interest in the corporate world is agents. I have seen some fantastic results from a lot of research around an agent's ability and the grouping of agents to do just some fantastic elements. What I like about agents is they're goal-oriented, they're very autonomous, but they stay within their domain of knowledge. So yes, you might have a series of agents that are querying an LLM, but they're not going to go outside of that domain. So I can do a lot of really cool things with agents. One of the experiments that we did is we took a red teaming methodology with about 50 agents, and each agent could only do a certain thing. And we went and pen tested an entire cloud infrastructure with our agents. And we found that outside of being able to do privilege escalation to check if something was just like a root account or an admin account on a system, because that took like extra clicks, we did about 95% of a complete pen test with autonomous agents. And the only LLM we used was Claude on the back end. And each of those agents had a different approach. So we would check for net BIOS, and if net BIOS was found, that agent would pass it on, and we would start looking for SMB roots and different elements, right? So we had this whole big, it was an ethical hacking exercise. The reason why that was fascinating to me is when we tried to do that same approach with just an LLM, it was vastly inferior. So an agent-based approach, especially task-oriented agents, are very, very powerful. If you can leverage a large language model as the core intelligence, again, you can be very effective with that and avoid things like hallucination or bias or drift, right? Because again, you're staying within that key element. And the difference between an agent and a chatbot is the interaction level. A chatbot wants to do something, to interact with you and do it, give you a return of information, where an agent is specifically programmed for a task. So one of my other favorite projects that we did is Anthropic released MCP, which is a fantastic framework for just messaging in general across different AI systems. And we have a coding assistant. And the coding assistant can do some entry-level coding and some mid-level coding. We couldn't get it up into the more expert domains, but we were able to basically create a GitHub repository or GitHub, post a repository in about 5 minutes, and the agent knows how to do that over and over again, right? We tied it into different elements, so very, very powerful, lots of relevancy to use cases. But without guardrails, even though they have isolated domains and they're only inferencing like a core for an LLM for centralized intelligence, you can still do a lot of things. So like an incorrect planning logic, as an example, could be exploited for literally to exploit an undesired outcome. So in my coding example, if I had somebody who did memory tampering and decided to hit my planning logic, then what I could start doing is third-party supply chain attacks, start injecting code into different places, right? Maybe set up some honeypots and malware in different elements, and my agent doesn't know any better. I think my agent is working just fine because I have no observability. How am I going to know if my agent is doing that, especially if I'm not able to detect that? And again, this goes back to the challenge of having AI democratized the way that it has been. These virus definitions, this threat intelligence, it doesn't exist yet. Yes, the vulnerability databases exist, absolutely. The responsible AI frameworks exist, absolutely. But you're not going to be able to just attach a system to this and just have it holistically give you that observability. And I'm not talking about model observability. I'm talking about the mitigations, tactics, and procedures like I showed you in the MITRE Atlas framework, right? So that's where the guardrail approach comes into play. Because if I have a bunch of agents, if I have 50 agents and I can red team and I can pen test against that, and I have a logic exploit, well, that is not a good thing, I can tell you, and that is something that you're going to want to get. And these are going to be the targets. The bots and the agents are the targets because they are what is connected to the enterprise software. They're connected to the data that is, that's what you want, right? And so, again, even if it's a reconnaissance or an evasion tactic, model tampering and data exfiltration are what your actors are going to try to want to do. The other element that has really taken off, especially over the last couple of years, is retrieval augmented generation. It's a really powerful way to provide high value AI integration without fine tuning, essentially, right? There are a lot of foundational developmental frameworks, MemeGPT, OLLAMA, Llama Index, and when you look at the vector databases, like my favorite, I like Pinecone and ChromaDB, but I can have a system that can go to an external source. Let's just keep it simple and say it's a vector database. I can vectorize any information I want, and the model itself doesn't have to change how it's fine-tuned, its weights, and its biases, because I'm going to be pulling that from an external source. Well, another thing that I can do with RAG is prompt engineering. Prompt engineering is I actually took a class on it last year. It's a fascinating technology to me because I can actually shape the way an LLM interacts and stores and generates responses. And via prompt engineering, I'm not a data scientist, I'm not an ML engineer, but if I know what I want that LLM to do and interact with, let's say I'm in sales, and I know I have a type of customer that I want to outreach to, and I've got a really nice sales database, and I want it to craft messages for me. I want it to, profile, a certain buyer constituent prototype. I'm not going to spend a lot of money on that. I don't want to have all this fancy stuff, right? So from a prompt engineering perspective, I can train my system to interact the way that I want. Well, just like everything else, it's a double-edged sword that goes both ways, right? So if I can prompt engineer it, well, what do you think other folks can do from a RAG perspective? So raw data compromise and accuracy and reliability it's an integrity attack. It's different than poisoning because I'm not doing malicious inputs, right? I'm tampering with it in a way that is going to compromise accuracy and reliability. So that's where I'm going to maybe do a degradation attack and understand what I can and can't have access to. But data leakage is what I'm after. Poisoning attacks is what I'm after. If I do a poisoning attack and I disrupt the machine learning model, I have a chance of getting leakage of data. What is leakage of data? Well, it's PII, it's financial, it's all of those things. And I can get unauthorized access to a back-end system. So one of my favorite elements with Copilot, as an example, invisible text. It's a pretty nasty one. They were able to send Unicode, malicious Unicode, which is basically metadata about text. The model read it. So it wasn't in the actual ASCII. It was in the Unicode. And what we figured out quickly is A user didn't even have to click on the link or open the email. The model itself executed that. It's even more dangerous downstream with a RAG element, because if I'm doing injection attacks, I don't even have to speak English, right? That's an interface. I can speak machine code. Another element that I loved with OpenAI is we took a prompt injection, we translated it into from ASCII into hexadecimal, and the model executed it. Because it's not just English, it's not just Spanish. It speaks binary up, right? So these injection attacks and the manipulation of the database queries, going back to the prompt engineering, if I've got this connected to a database, I can actually modify what's stored in that RAG database downstream. And then, of course, tampering with adversarial model inputs. So, in short, these are the three major areas that I wanted to cover, in this time. Guardrails are essential. It is, again, it's not a technology discussion. It is a combination of understanding how to define a business case, apply a solution architecture that will basically create requirements. Those requirements then are met with, potential tactics, techniques, procedures, indicators of compromise. Then you lay down your controls and your elements. And all of those steps in general are what a guardrail is. And again, a guardrail is meant to be very specific to the business logic of that AI instance. And it's not going to be the same anywhere. It's very bespoke. And it requires a lot of communication and a lot of different expertise. So when I say that the adoption of artificial intelligence in an organization is an organizational responsibility, I mean that because it takes more than one expert of domain to be able to fulfill that. How are we doing on time? So I'll open it up to some questions or comments at this time. Let's see what we have here. Does it look like we have anything online? Okay. Yes, sir.
For that one example that you gave about working with a finance company, you mentioned how having one AI model do everything wouldn't be good because of the regulations, but could you have intermediary programs?
Press his mic to talk with.
Oh, sorry.
There's a microphone right in front of you on the table.
You can use it.
Oh,
Press.
can you guys hear me?
Yep.
Awesome. So basically, in that finance example, instead of having the model do everything directly, could you have intermediary programs that sort of, one that filters the email input and passes certain things to a model, one that filters the message input and passes it to the model, and by having that extra layer of indirection, make it actually so it's compliant with regulations?
Absolutely. So that's a great agent-based approach, right? So if you had, let's just use agents in that example, and maybe even a RAG aspect. So if I took LangChain and I took some agents and I created an AI flow, absolutely, because I can put specific guardrails around each one of those elements. And if that system is owned by that organization and they can show how they're protecting it, how they're measuring the responsible AI elements, so in other words, what it's doing, how they're doing it, and you have those security controls around it, that would be compliant. Because I can show those controls, I can show what the model's doing, and it's even better not to have it all in one system, like you said, because I can ensure that those domains of those agents are only doing specified things. So again, I can have one that's combing email, I can have one that's doing like maybe note dictation, I can have one that's looking to make sure that those two elements are landing in the repository that it needs to be in to show that evidence, absolutely. And that's the value, right? If you go back to that use case, what you just did is you applied a solution architecture approach to that by thinking, okay, what if I took this and broke it down into simpler parts? Maybe an agent-based approach could do that. That's absolutely how you should approach it. Very well done.
Thank you.
So how do you think the kind of maturity of the technology versus kind of the level of maturity or established presence of the business would kind of influence how this framework works? Like say ChatGPT and its variants have been around for a lot longer than the kind of sudden emergence of DeepSeek and the rapid attempts at integration of it. So how would something like an entrenched finance company handle things versus, say, a startup that's prioritizing using the latest and greatest kind of under these frameworks?
Yeah, great questions. Technical debt is always going to be an issue. And I would say from a financial expert perspective, or let's say an organization that maybe even made an investment, that's going to be one of the challenges of how AI changes over time, right? And so if I've got my use cases defined and that's what I'm focused on, and something better or more accurate comes out, I'm going to be able to apply that logically. The ability to take requirements and show the alignment of functional requirements, which is a direct representation of that system, versus non-functional requirements, which would be things like compliance, cybersecurity, that's going to drive the functional requirement. That's what's going to happen. What we're not seeing with this is the businesses are just going out and using this SaaS offering in a shadow AI perspective, and there's no synergy, right? And so when like a startup as an example, they're going to be at a much higher advantage because they're going to probably go out there and look and see at what is viable and what can I use and how would I go and do that. Whereas a larger organization is going to be at a much harder, let's say, digital transformation aspect to be able to do that. But lastly, even if you approach it that way and you don't include, I would say, your governance and compliance and cybersecurity, holistically, you're going to have that issue. The issue that we have today is this technology it's already here, right? It's already being used. And I don't want this to be doom and gloom, but this is a very big skills gap, right? These conversations aren't happening not because people don't care, they don't know where to start. They don't know what's out there. They don't understand, and it's not that they're not intelligent people, they are. But think about, well, this is well below your time, I'll show you a little gray on my beard. This is the internet in the late 90s, the same thing, right? This is an apex technology that is going to change everything. And if you don't adopt it well, then you're going to get blown by. But you're absolutely right. Combining digital transformation elements, understanding dev cycles, having an ML SecOps practice, that is all mandatory building blocks just to enable the ability to change as AI comes in different elements. I can't even imagine what we're going to see in 5 years. I mean, look at what you all are going to do, right? What is the university's mantra? Physical AI. That's a pretty cool place to be when you're talking about, I'm not just going to want to interact with something on a language level contextually. I'm going to actually look at a hardware data set. I know that I can take this 20 gigabytes of information and turn it into something. I don't need it to be a 400 billion parameter model. I can make it an 8 million parameter model and it'll do the exact same thing. That's what you guys are going to drive. Any other questions?
Okay. How coachable? Oh, okay. So famously, one of the cases that started the interest in responsible AI was, I'm sure you're familiar with the case with Compass, which was an algorithm made to provide insight for judges regarding whether or not someone was likely to commit another crime after they were prosecuted. And famously, it had a less than 50% accuracy or something like that. It was a coin toss and it was still being used for decisions. And that started the conversation about explainable AI, surrounding explainable AI. I know your lecture was specifically geared towards guardrails, but how do you see explainable AI being integrated into guardrails and jurisdiction around surrounding AI in the future?
Great question. So that really starts with your classification of your AI system. What you described is a high-risk AI system. It has a societal bias, and AI is woefully horrible at, understanding what is fair. That doesn't exist with AI, right? You can use a healthcare example in the same context to determine if, you're prone to heart disease. There's so many external factors to that. So explainable AI would be very important in the solution architecture phase, right? The reason why is if you're not using known technology where you can really have a trust, right? So you're not just going to go to Hugging Face and download an open source model without looking at the training data, seeing where it came from, what is bias, and it's model card, if you will. I think that explainable AI has to just be a mandatory building block. It's a prerequisite, right? If you're not looking at it, even if I am wanting to write an email and I'm using at it from a sales perspective, from a low risk AI system, I still want that to be accurate. And if we don't have the ability to show what AI is doing, then that is a fundamental failure in guardrails in general. Now, observability as far as model training and machine learning operations, that's just part of, again, going through that process to ensure what you're training the model to do, it actually does it. What we're talking about here is the adoption of AI. And if I can't say, okay, I can use OpenAI to do certain things, but I'm not going to trust it unless I know that this high-risk system, even if it's a financial algorithm, can be done. So those soft skills, if you will. A soft skill is well beyond technology. It's the ability to, again, say, well, I don't think this is a fair and safe approach, and I don't think we're going to see anything in that realm for a while. Where I personally think we're going to go is what I said, where what Purdue is starting to do with your physical AI. It's going to be, let's put this smaller model closer to the physical layer. It could be a computer, whatever, and that is what we're going to be using from a data set perspective, right? Closer to the edge. What you see today is just the beginning of AI. These large language models are super great. They've done a phenomenal job of, like I said, being able to have organizations adopt them. But it's a business approach, not an AI ML approach. That make sense? Great. We were tricked. Anything else? All right.
Oh, sorry, one last question.
Yes, sir.
What was that example that you gave earlier about people embedding things into the chatbots? I remember that you mentioned it was a huge problem, but I actually didn't understand what they were doing. I don't know if it was a...
Oh yeah, let me go back real quick.
Okay, thank you.
You're good, man. Absolutely. So long-term memory, right? So if you just go, so let's take the chatbot element out of it. Let's say you just go to ChatGPT and you use just a regular instance. Have you seen at the top where it says memory or memory full?
Yeah, I've seen that before. I think I understood the technical details of what they did, like how they injected bad data that was coming up occasionally. But what was the actual data that they injected? What was kind of their practical purpose for doing that attack?
So a context-aware chatbot is, in theory, could be highly capable, very similar to your explainable AI question, right? So I don't just want to put a context-aware chatbot out there unregulated, unsupervised, because it's going to, just without a malicious tactic, it's going to hallucinate. It's going to drift. It is. It's the nature of AI, right? So well before it was identified as a tactic, which again, a known hallucination attack is where you maliciously put something adversarial into a model. Hallucination was a machine learning aspect, right? We wanted to keep the model within the efficacy that we trained it, and it needed to stay there. So in this case, from a context-aware chatbot, the in-memory elements, I can embed malicious things in there and change what it's meant to do and in a way that is undetectable. And again, that's a challenge because context-aware chatbots are really cool, but they're also very susceptible to a lot of tactics and elements. So you have to put those guardrails in. You have to have the observability for the explainable AI. So that's what I meant by that element. Because we're not talking the technology, we're talking about the use case and how it will be used and the dangers of not putting guardrails around it for folks that don't necessarily have that technical background.
Okay, thank you.
I might be, you can correct me if this isn't an example, but I think there is actually very recently came out that Russia was like dousing the internet with pro-Russia propaganda, and it was influencing some of these chatbots that train off of internet data, so that it was returning a lot of pro-Russia propaganda, which I think is kind of an example of
Yeah,
that.
I mean, again, it's a prompt engineer. You're having it learn what you want it to learn, right? We've seen that with social media. We're not changing data. Again, AI is using data, right? That's not changing it. But if we don't put these guardrails down, I'll go back to this slide here. We are talking about an entirely new threat landscape, right? Cybersecurity frameworks and whatnot are still there. But if I am in an organization and I've got 27 AI systems and they're all SaaS and endpoints, how am I ever going to approach that with a traditional cybersecurity? It's not going to be behind my firewall. It's not going to hit my identity system, right? That's where shadow AI is super dangerous. So if I'm doing that and I have these super powerful, like context-aware chatbots, that's a high-risk system. You have to take that very seriously. You have to put those guardrails and you have to measure it. You have to have the observability and the explainability. Because if somebody does compromise your long-term memory, well, that is called a materiality data breach, where you probably will have to report that to some regulatory agency, and then you're going to have to do some explaining.
Thank you.
Yeah.
So kind of in a similar trend then, how do you think the kind of process of setting up guardrails and ensuring like proper training of models, considering the risk of poisoning, the risk of models
that learn as they go being poisoned,
how do you think
that kind of intersects with how a lot of models are being
trained? Because a lot of models need exponentially more and more data for better approaches, at least by conventional architectures.
Sure.
And I mean, we see mass scraping of the internet, mass scraping of pretty much anything ever.
That's true.
So how do we kind of reconcile the two, the need for high quality, trustable data, but also the sheer volume?
Yeah, so you got to go low and slow. You have to start with proper data sets. You have to label your data. You have to put them in a way that you can measure it. And you're not just gonna, I'm gonna take, let's talk about threat intelligence, right? I'm gonna take 5 categories and I'm going to put a bunch of tactics in there. Okay, let's say I take Llama 3, whatever, 8 billion parameter model, and I know it's got the ability to do some basic reasoning. I'm gonna fine tune that. What is the guarantee that the accuracy and the classification of that event and map back to that tactic is accurate? How do you measure that? Well, you can go back to your training data. You can go back and look at did it classify it and whatnot. But that's what makes this hard, and that's why people are not going down that path. To your point, scraping the data and pulling all that in, that's a lot of resource, that's very time intensive, and do you have access to the computational power needed to do that? So instead what's happening is I'm just gonna go pay OpenAI $40 a month. I'm just gonna send it to there. I've got some basic logging, and sure, it works just fine. But I'm not controlling the bias. That's a black box model. So there's a difference between a white box model, which is what you're describing, right? A white box model is I know what it is, I know I trained it, I know the bias, I know what it's supposed to do, I can measure it, I probably have an ML ops pipeline, I know how to pre-tune the data, and I'm gonna measure its drift and have my observability and explainability. A black box model is I'm just gonna integrate it and go. That's the YOLO mode, and most people are going YOLO, absolutely, because it's easier, and that is what is introducing shadow AI. That is what is introducing a lack of guardrail. What you just described, the complexity of that training and elements, it's a very big process, and it doesn't necessarily guarantee you have access to complete training data sets. So that's a white box versus black box type of an approach. Any other questions? Excellent.
Nope, I don't see any more questions. So thanks a lot, Tim. Thanks. We really appreciate you coming here to Purdue. And I think you're going to be participating in our symposium next week also. So any students that are in attendance, if you haven't signed up for our symposium, you can go to the CERIAS website and sign up there.
We will also be talking to some student groups who might be interested in some of the more advanced integration around guardrails for ComplyQ as well. So I'm looking forward to interacting with you all. Thank you very much for coming this evening. It was nice meeting you all.
All right, thanks a lot.